guests and ladies and gentlemen, it's a pleasure for me to be here. Previously, when I visited the region, I was talking about another network, the internet. And I had the privilege of working with many of you across many of your countries to think about the impact that high-speed had and broadband had on our ability to capture the potential of the digital world. So 6 months ago, when I joined Hyperloop, you can imagine how thrilled I was to imagine there was another network that could bring the power of speed and new capacity to the physical world, to moving bits and atoms. And that's really what I think we're talking about today. Because when I think of transportation, we're just not keeping up to the growth in traffic. We heard about population growth. We hear of massive container ships hitting our ports with 18,000 containers. We're challenged with offloading them as quickly as we can and using more valuable land in some of the most beautiful places of the world. So I think the capacity of today's transportation systems must change. They must be faster, they must be more connected. We see their reliability challenged. We see congestion on our roads and congestion on our ports as more and more containers arrive. We've heard this morning of the impact and sustainability of today's systems. So really this view that something must change and we must see some new innovations coming to the world of transportation, I think it's something that we all agree with. But there is innovation, it's everywhere. I flew here on a beautiful A380 Airbus, a marvel in the air. When I left my home in Northern California, there were Google self-driving cars all around Mountain View, driving millions of miles a day in an autonomous fashion. We see drone deliveries, we see the beautiful metro here. There are many, many innovations in transportation, but they don't feel connected. They don't feel like they have a backbone. And I believe the construct of Hyperloop is to bring a very high-speed, fifth mode of transportation to the world and connect all the innovation that's happening today. And integrating that innovation so we can really solve some of the challenges that I think we all face every day. So what is Hyperloop? I think it's the new broadband for transportation. I think it's a high-speed network that allows us to achieve speeds never perhaps thought possible as we apply existing science in a much different way. It's additive to today's modes of transportation. It's not a replacement for trains, a replacement for cars. It's a fifth mode. And I think it's additive, and I do believe it will allow us to move people and cargo faster, greener, safer, and more cheaply than we may have ever have imagined. And it is happening much more quickly than we could also imagine. So the idea of Hyperloop was something that was surfaced by Elon Musk, the founder of SpaceX, the individual who founded Tesla, and also runs a company called Solar City. And instead of doing it himself, he threw the idea out in a 53-page white paper in August of 2013 and said to the world, go build it. So our company was formed by two co-founders. One of them was employee number 25 at SpaceX. He built the rockets that have gone to the manned space station and back, and he says that our project is easier than building a rocket ship, but hard enough to be challenging. And also an individual investor who's invested in the early rounds of Uber, Airbnb, and other on-demand technologies that have really changed the landscape of today's transportation infrastructure. But our company is an individual startup, funded in the traditional ways in which startup companies have been funded in Silicon Valley, and it's actually tackling the engineering and developing the technology that we believe will make Hyperloop a reality in a much shorter period of time than many thought possible. So let's take a step back, and just for anyone that hasn't heard of this idea, let's describe what is Hyperloop. Tube-based transportation isn't a brand new idea. It's actually been around for years and years. What we're actually doing is taking the construct of a tube. Think of this similar to a gas pipeline or a water pipeline. We can build it today. Our innovation is to bring the cost of the materials down and actually the cost of the manufacturing process down, but it's basically a very large-scale tube. And then we remove much of the pressure from that tube using standard industrial pumps. We'll equate a pressure of around 100 pascals, which is equivalent to the atmosphere at approximately 160,000 feet above the Earth. And then once we create that low pressure environment, we create much less resistance, resistance that requires energy to move an object through that tube. So we don't have the same resistance. We then use levitation, and we use a passive system that actually levitates the pod. Could be a pod containing cargo or a pod containing people. And we levitate that without using any energy. Just the motion itself creates the levitation. We use an electric motor that is only required for 5% of the distance of the tube. And we use that motor to propel very quickly the tube through that surface. And as a result, we can achieve incredible speeds, 1,100 kilometers an hour, over 700 miles an hour. We have very little resistance, we use less energy, and we go really, really fast. And even if there's still a bit of buildup, we have a compressor at the front of the pod that removes any remaining pressure. None of what I've described requires any new science. It can all be built today. What we are doing, though, is applying the concept of a startup and different ways to build things quickly that will allow us to happen more quickly than it has been possible in the past. So what are we trying to do? We're trying to move cargo, freight inside a pod. We're trying to move people in smaller increments. We're not building a train. We're actually building just a smaller unit containing maybe 30, 40 passengers, a smaller unit containing 1 or 2 20 FUs, and actually moving those very quickly directly from the source of destination. Now that tube can be built overland on pylons, very much looking at the metro as we come into Dubai. It can go underground in tunnels. Remembering as you have less pressure, you need to build a very much smaller tunnel in order to move through the object, which significantly decreases the cost of tunneling. And it can go underwater. So that opens up a whole new set of applications in ocean areas, around ports, and even across connections that may be across shallow water. And most importantly, it's on demand. We're not going to build a long train or large platforms. The idea of Hyperloop is it's more like this. It's more like just an on-demand system. There's no schedule for Hyperloop. You arrive, you go point to point, you don't stop along the way. We'll switch on and off the main track, just like a network does today. And so our idea is to packetize the movement of people and goods the same way the internet packetized the movement of digital data. You don't stop along every way. You bypass certain routes. So for high speed, we don't stop at every destination. We'll only go to the eventual destination. And that's a really big change and a really big idea, and one that will allow us to achieve speeds and actually shrink the distances between cities in ways that's never been thought of. We're also talking about a new experience. We're going to use a lot of capabilities in creating the kind of experience that an individual would want inside that transportation environment. Do I want to watch television? Do I want to watch virtual or augmented reality? And it will be something quite different. I don't want to think of this because people have said to me, what if I can't see outside? Will that make me feel uncomfortable or nervous? And so I think we'll create some new kinds of experiences using available technology that will allow us to create a personalized and customized transportation experience. But most importantly, this changes everything. With these speeds, up to 1,100 kilometers an hour, we can create an on-demand economy with the backbone of transportation, so manufactured goods that occur in the fashion industry or in the electronics industry could move across continents in days rather than weeks. We wouldn't have to move everything by container ship or by airfare when it's required. We would be able to move along land in a much more cost-effective and actually efficient way. Certainly transforms the way we think of a city. Today, cities are typically defined by the length and time in which people can travel and work between cities. That eventually defines the convenience of moving. But right now, if you can move 300 miles between city one and city two, live in one and work in another and get there in 20 or less minutes, it really does redefine our concept of a city and of suburbs that are being built today. It certainly reshapes how we think of the cargo industry and the freight industry. The rail line today, as you might know from Vladivostok to Moscow, is around 14 days. We could do that same distance in 12 hours. And by moving cargo from the gateways of China to the center of Russia in 12 hours, that really redefines the whole construct of supply chain and logistics. As we move much more quickly to offload ports and maybe redefine how the real estate amongst the world's greatest ports is used, we can really transform that idea, and we can shape things in ways that have never been thought possible. We can remove the amount of inventory in supply chains as we apply speed to this capability, and we've discovered we also can redefine the value of real estate. We can move logistics centers and intermodal centers to places where they perhaps couldn't have been before, and then redeploy that often urban, valuable real estate in ways in which people can live, enjoy, and be and use for recreational purposes. So that is a big opportunity we also see. A couple of examples. The idea of an airport, and many of you are involved in transportation systems that actually move in metro areas. We could imagine connecting the 3 airports in the UK, for example. London Heathrow is out of capacity. Stansted is not up to capacity. And the other airport, which has just slipped my mind, has the capacity amongst those 3 airports, but if we could move 50, 60 miles between those airports in less than 8 minutes, it would be just the same as taking a shuttle between terminals in virtual airports. And we could see that also emerging in the region as well. The idea of creating a virtual airport or a virtual runway when we add additional capacity far away, but the journey to move from a runway or a terminal to another airport would be minutes. The same as moving from a terminal in today's intermodal areas. The idea of redefining ports, changing how we think of ports. Ports today sit amongst some of the world's most valuable real estate here as well, in the beautiful Gulf region. So why does a port need to be on the shore? Certainly we need to offload containers, but those containers and even customs clearance could occur somewhere else. It could occur inland. And we're right now looking at the idea of dry ports, where we take a very quick offloading of the containers, very rapidly offload the containers to an intermodal area, perhaps 50, 60 miles from the port, require much less dockside capacity, and then perhaps redeploy or increase the capacity of ports to handle the increasingly large ships that we see arriving every day. We also have the ability to do this using existing right-of-ways. We can go underground, we can go above ground, we can even move offshore and look at the idea of an offshore port. And right here in Jebel Ali, we've seen the projects constructing Terminal 4, truly dredging the capacity of an offshore port. We could imagine Hyperloop being deployed in an environment where we build a port offshore and then have the tube actually transport the freight onshore, clear past the city, and create a new intermodal area of distribution. So it really helps us imagine reallocating the way in which land has been used, redefines the concept of a port, it redefines safety and customs clearance because we are moving goods in a closed environment. So as we heard earlier from one of the speakers about moving goods across different borders, once we have that closed environment, it's much different in terms of the context of anybody being able to interfere with cargo or interfere with customs clearances. So it all sounds very futuristic, but it's actually happening now. Our company has acquired 50 acres of land. We've raised over $100 million of capital to invest in this project. I'll show you a quick glimpse of a video we took from our 50-acre test and safety site that's under construction right now in North Las Vegas. So I took the video last week. Maybe we could just take a quick look. So this is the actual beginning test of the motor system. This is the full-scale tube that's on site today. We have over a half a kilometer of tube as we begin the work of building our first 3-kilometer full-scale test track. That's all the elements of propulsion. That's all the elements of the levitation technology. the tube construction, and this is actually an 11.5-foot steel tube, basically made out of today's materials. We're innovating to bring the cost down and actually be able to construct that in a very fast way. So we're beginning now, and this company is actually, it's a startup. And when I think of this team, I've got our founder here, Brogan Bam Brogan. He's a guy that's built rockets, and he was employee number 25 at SpaceX. Everything we're doing is not to just sit behind a design computer and test things. We actually design, we test, and then in the University of Elon Musk, the lesson is go and build at full scale. Don't build a model, build at full scale. You'll learn twice as much in the same amount of time. So right now we have 100 employees. We've raised a lot of money. We're going to raise more. We actually have, we have a 50-acre test site in North Las Vegas. We filed 35 patents for some of the emerging technologies we're developing. We have a 55,000 campus, 55,000 square foot campus. When I left, we had 120 employees. There'll be more when I arrive home at the end of the week. There were 44 when I started 6 months ago, and there'll be close to 300 at the end of this year. So it's a very exciting project that's addressing and attracting some of the brightest minds in the world. We have PhDs and masters across all engineering disciplines who want to see this happen. They want to see Hyperloop become a reality. And it's creating a tremendous amount of excitement and a tremendous amount of energy. Our investors are from around the world who actually see the potential of building a fifth mode of transportation that will allow us to live anywhere, to work anywhere, to be anywhere, and to actually do anything in the world of transportation. So I want to thank you very much for your kind attention. There may be some questions I'd be happy to take, and I've left a little bit of extra time to take your questions if you have them. So thank you very much.
Right, so if anybody has any questions, kindly raise your hand and we'll get you a microphone. Yes, there's one in the middle.
Yes, hello, my name is Katrin Obst. I work for the European Commission in Brussels. Would you be able to give an estimate as to how expensive Hyperloop would be compared to high-speed rail?
So we've been working with some international accounting firms, and we've been working against the existing models of high-speed rail. We expect the cost of constructing this system with known materials will be about 62% of the cost of high-speed rail, and the performance will be 3 times faster. The energy consumption per passengers will be approximately the same or slightly lower. So the energy consumption, including the removal of the air pressure and the maintenance of the low pressure environment, the electric propulsion motor, and all other elements of the system will be a little bit less in terms of operating energy, will be much less in terms of maintenance, and will be about 62% in the capital cost. Remembering that major bridges and land acquisition costs should be significantly lower because the right-of-way we need to accumulate is much smaller. It would be a right-of-way more equivalent to the metro that I see in Dubai than a traditional high-speed rail construction.
Right, do we have any more questions? Okay, we have time only for one more question.
Let's do 2 more questions.
Right. You're cool.
Suleiman Reda from Kuwait News Agency. Regarding the safety of this project, it's really something important, and we in GCC country, you know, sometimes environmentally it is different than other parts of the world. So talk to us about the safety of this project in this area where the temperature sometimes it reaches more than 50 degrees.
Yeah, that's a very good question. And actually, we think working with safety regulators around the world is a key focus. We're also working with many operators right now that are interested in sharing their experience in the rail industry and in the aerospace industry about safety concerns. We do want to work with regulators. We do want to understand the heat and other implications. We have some ideas as to how to deal with that, but our view is we're going to start with freight first. where we think it's a much easier environment for us to actually work with regulators and achieve the appropriate certifications, and then we'll move on to passengers in that sequence. And I think we're looking forward to working with regulators and leveraging the experience that many of you have had in creating an extremely safe system. Inherently, the system has some advantages in terms of safety. It doesn't have the interference of sand. You can't throw anything onto the track. There's no snow or environmental interferences. As a closed system, there are some advantages, but as well, we need to think about escape and other mechanisms. We're going to go freight first and then passengers next.
Ibrahim Shir from Saudi Railway Company. I've just seen that you guys are going to the next level of implementing this, but my curiosity is about accelerating and a lot of G's that you would apply to this vessel. And whoever going to be in this vessel moving in high speed like this, from accelerating from 0 to 1,100 kilometers per hour or something, in a long distance would expose them to very high risk of pressurizing the vehicles inside and outside. So I don't know how would you equalize the pressure between inside the vessel and outside the vessel with high speed and low speed movement of the vehicle.
So I think there's a couple of questions there. The first is equalizing the pressure. Regardless of if it's a container, straight off a container ship, or if it's people, we'll have a pressurized environment inside the pod, and we know how to build those environments through aircraft and other environments operating like that. Remember that if there's a breach in the tube, the actual catastrophic environment means the tube fills with air. Air is a natural braking mechanism and clearly creates a safer environment should that happen. The second, I think, part of your question was acceleration and G-force and the experiences that we'll have, remembering that the G's that we can apply to a container of cargo are much different than the G-forces that are comfortable for passengers. We expect that the G's that we'll use in acceleration will be probably in the neighborhood of 0.6 to 0.8, very much similar to taking off in an aircraft. And that is all depending on the length of the distance that we actually use to propel the pod. So think of it as a dial that allows us to apply the appropriate amount of energy to achieve those speeds. The initial acceleration phase would be a couple of kilometers, so we can clearly see ourselves reaching those kinds of speeds over a couple of kilometers, and probably feels very similar to riding a high-speed elevator here in one of the beautiful buildings in Dubai. So G-forces will be specifically adjusted. Routes really matter, and the straightness of the route will be very much a determinant as to the eventual speed that we can travel. But it is not the physics of the system.
In case of accident or earthquake or air leak, is there any measures or consideration to the evacuation process for if we have passengers in this?
That's a very good question. So we're working right now that this will be a very connected system, and we will need to build a control system based on many of the principles of autonomous vehicles. This will be an autonomous system, all automated. So we will be leveraging some of the experiences we've seen in autonomous trucking, self-driving cars. The question about seismic activity or an environmental disruption would be very much based on some of the sensors that will be across many of the key components. Sensors on the tube, and the tube we expect to expand in the heat and contract in the cold. There'll be some movement as there's seismic activity and pylons move over time. The precision will be in the track located inside that tube. Sensors on the tube, sensors on the track, sensors on the pod, speaking to each other, and a next generation control system that will be based on how this technology is built, not on how the rail technology evolved over a century. So we'll be building a brand new control system to help us anticipate environmental disruptions and then kick in appropriate safety measures. And we expect to learn from many of you in this room that understand how those systems need to be constructed. So I want to thank you all very much for your kind attention. And one more question.
Hi, good morning. Thank you so much for that presentation, Rob. My name is Dina Kamel. I'm from Bloomberg News in Dubai. You touched briefly on a couple of ideas of how the Hyperloop can potentially link airports and even ports. Since you're here visiting in the UAE, have you had any discussions with the airports in Dubai or Abu Dhabi, as well as port operators like DP World on potentially bringing this idea here to the country?
So the question is there any opportunity to take some of these great ideas and apply them to the port of Jebel Ali, connecting these fantastic airports not only in Dubai but in the region? The answer would be we truly hope so, and we would expect that the history of innovation in this region could make perhaps Dubai and the United Arab Emirates one of the first places where Hyperloop comes into production. Our goal in the next 3 years is to select the top 3 projects in the world where we can build Hyperloop, we can demonstrate its capabilities, and we'll be working with innovative companies, innovative regulators, and innovative governments to try to make that a reality. So our dream would be that it happens here, and we'll see if we can make that dream come true. Thank you very much.